Greetings and welcome back to yet another episode of Lua Tutorials, and in this one we'll take a deeper look into loops and how we can iterate through a certain amount of code a finite amount of times, which means that we can repeat a certain code like 20 or 30 times, or we can repeat until a certain condition is met. And with that said, let's just jump right into it. So the first loop we're going to meet is called a while loop, and a while loop is simply a loop which repeats while a certain condition is true. So let's just say that we have a variable called a and we assign it a value of 5. And then we say, while a is bigger than 0, do the following. Let's just print out a value of a is a, and then we end it. So what ends up happening is the while is a condition or a keyword which indicates that this is a while loop. And then it's our condition which has to be true in order for our loop to work. Remember, it's while this is true, do this. So do the following line, or a multiple amount of lines. Of course, you can always enter as much code as you want between the while and the end. And then, of course, the end at the end, so you indicate that this while loop ends here. So what ends up happening if you just run this, you can see that it will output a or this prompt a lot of times. And that's because a value of a is not changing, right? A is 5, and because a is always bigger than 0, so 5 is always bigger than 0, this is gonna keep repeating. So let's just say that we wanna do something like this. A is a minus 1. And we just run this and you can see what would end up happening. Let's just, for better readability, just have one line. So value of a is 5, then of course it gets reduced to 4. This condition is still true because 4 is still bigger than 0. Then we output 4, then we decrement it to 3 again, 3 is still bigger than 0, we print that out, then we decrement it to 2, etc. until eventually a is 1, and a gets reduced by 1 to 0, and because of course 0 is not bigger than 0, in other words, this becomes false, this stops executing. So while loops work while the condition is true and stop when they are false. And while loops are usually useful when you don't know how many times a certain thing will repeat. So let's say that you want the user to input a number, and you keep checking if the type of the entered number is an actual number value or a type, and as long as it isn't, you keep asking the user with a while loop to enter until that certain variable is a number. So with that said, that's a while loop, and let's go on to the next one. The next loop we're going to look at is called a repeat until loop, and a repeat until loop is simply a loop which works in a similar way to a while loop, and it goes something like this. So let's just say repeat, print repeating until a certain condition is met. So let's just say that we have a variable called a and we assign it a value of a banana, and we would say repeat until a is a banana. And in this case what would end up happening is we would start the loop with a word repeat, which means that we want to do this, whatever is written inside it, so execute this code until this condition is met. So unlike a while loop, this loop stops when the condition is true. Of course, while loop stops when the condition is false. So it's kind of a reverse psychology or a reverse condition than the while loop. So, but it follows the logic of the English language. So while a certain condition is true, do something or repeat something until a certain condition is true. Another benefit, or I guess unique aspect of this loop, is that whatever your condition is, like in this one, when it's met, even though it is met, you can still it still outputs the number or the value or the code inside once. So that's because this has a unique property that even though your condition or you don't want your loop to execute multiple times, the code inside is still gonna be executed at least once. So in this case, sometimes that's useful. I don't use it very often in my own programs because everything can be written with a while loop and the for loop we're going to meet next. But sometimes you just want to execute your code once and then decide maybe if you want to loop that part again. So maybe, you're writing again a program which reads the user input, and you know that you have to read the user input at least once until a certain condition is met. And in this case, a repeat until loop would be useful, but again, like I said, you can write all of those things with the while loop or any other loops, but this is just a loop that you can use, and of course, if you get used to it, that's great, there's nothing wrong with that. But one thing to keep in mind is that it does execute its code at least once, even though the condition for the looping is met, and the loop condition, this loop executes more times if the condition is false, and it stops when it is true. So it's just the opposite of the while loop. So let's go to the next one. The next one is called a for loop, and a for loop is simply a loop which executes a certain amount of times until we get to the value we want. So the syntax for the for loop looks something like this: for I is 1, then 1, do print. Let's just do it like this. So it is a bit daunting because it's not like any other loop, but what it means, first of all, we create a new variable called I, and we assign it a value of 1, and this repeats until the I is 10, and we increment it every step by 1. And we just run this, you can see what ends up happening is we print I on every step. So for loops are usually very useful when we know how many times we want to repeat something, unlike any other loop when we only repeat until a certain condition is met. And the first, like I said, is a new variable called I in our situation, and usually they are following, these variables, counter variables, start with an I, then go to j, k, l, m, n, o, p. So if you have multiple nested loops, so one loop in another loop, in another loop, in another loop, you would usually, or you would see usually that little rule followed, that they start with an A, I, and then just go to j, k, l, m, n, o, p, etc. And then it's our end goal, which means that when I is 10, this loop will stop executing. And then the last one is by how much I increments on every single loop. So in this case, if you just say 1, it means that every single loop our I will increment by 1. So that's 1, 2, 3, 4, up until 10. Of course, if you change this to 2, what would end up happening is our value of I would increment by 2. So that's 1, 3, 4, 5, 7, 1, 3, 5, 7, 9. And of course, if you change this as well, what would end up happening is it would only increment to 7, and then it would stop. So this is kind of useful in the, like I said, in the sense that we can control how many times our loop executes and how many times we can do certain things. For loops are capable of doing some other things as well with arrays, but I'm going to explain that once we get to that point. But at this point, just remember that the for loops are used whenever you want to repeat something multiple times. And I mentioned nested for loops, and that's just something I want to kind of show as well. So let's just say that we have a loop that goes to 5, and then let's create another loop inside. And like I said, the usual nomenclature, I guess, is that you follow the I and then go through the alphabet. And let's just print both values out at the same time. And then, of course, we have to end both for loops. And let's just delete this one because it's not needed. And if we run it, you can see how it works. First of all, the outer loop starts, and then the inner loop starts. And then the inner loop executes until, so j is set to 1. It increments it by 1, and we output I at every step and j as well. And because remember, this inner for loop will keep on looping until this condition is met, so until j is 5, and then only then will it stop, and then the outer loop can continue. So first of all, I is 1, j is 1, and then we print that both out, so that's simple. And then the inner loop starts repeating, and j is incremented to 2, and I in this case is still 1, and j is 2, so that's what we see. And then j is incremented to 3, 4, and 5, so in that case, I is still always 1. But when j hits 5, that gets outputted, and then this for loop ends. And then the outer for loop can continue, and in this case, in increments from 1 to 2, because of course the step is 1. So that means that we go back to the inner loop, because the outer loop still is executing, and it repeats the inner loop again. And then the I is 2 and j is 1 because the inner loop starts again. And then the j gets incremented to 2, so then I is 2, j is 2, and then j gets incremented again. So then I is 2 and j is 3, and then it repeats until j is 5 again. And then the inner loop ends and the outer loop starts, and then it's I is 3 again and the j is 1 again. And that kind of repeats until both are 5, and that ends. So in total, they execute 25 times. So that means the outer loop executes 5 times, and the inner loop executes 5 times. So in total, that's 5 times by 5, which means 25 times. And I know that nested loops are a bit confusing. I have one example to kind of showcase how you can use them to create rectangles. But just keep in mind that you can nest any loop, so you can put any loop inside of any other loop to kind of create this double down effect. And oftentimes that is very useful when you want to iterate over multiple step or maybe 2-day arrays. And of course, when we get to it, I'm gonna be showing you how we can do that as well. So let's go to the last things before the examples. So the last thing I want to talk about is called a break function. And a break is simply a way for us to stop a loop before it finishes doing what it's doing, before it reaches the goal it is destined to reach. And let me just give you an example. Let's just create a new for loop called something like this, and we print out I. And of course, if you run this, what would end up happening is we would get output at 1 to 10, which is as expected. Let's say that we want to execute this for loop until I is exactly 5. And one possibility would be, of course, to just write this, and that means that I would go from 1 to 5. But let's say for whatever reason we don't want to do that. We could utilize the break, and we could write something like this. If I is 5, then break and end. So what will end up happening when we run this? First of all, I is 1, and of course this condition is not met, which is false, so this if does not get executed. So 1 gets printed out. Then it gets incremented to 2, and this is still not true, and 3 and 4 and 5 finally. And when I is equal to 5, which means that this is true, the if statement gets executed, the break gets executed, which means that at that point the for loop breaks. And that is indicated because the print, even though I is 5 when this break happens, this print never occurs, which means that you don't see the I outside in the console being printed out, which means that at this point, whenever you encounter break, this is exactly where it stops. And break works on for functions or for loop, and it also works on whiles, or the return until loops, or maybe any other loops that Lua has in the newer versions that I'm not aware of. But breaks are just a way for you to stop the loops prematurely. And sometimes they can be used as double checks. Maybe, you want to have more conditions to check and you don't want to cram everything in just one line. Or maybe sometimes it's easier to write it in this logic, or maybe something can happen in your code to indicate that something is broken and then you want to stop the loop for whatever reason. So I just wanted to mention that this is a possibility of using a break to kind of stop your functions. Another thing I wanted to mention is that when we create this I function and when we stop the loop, or when we break it, or when the loop stops naturally, this I in a for loop ceases to stop existing, which means that if we wanted to print out I outside of the loop, it would not exist. You can see that this is a value of nil. And that's because I, when you create it here, only exists inside of this loop. And if you wanted to kind of save its value or last value of the loop, we would have to create a new variable called, for example, var, and then we would have to say that var is equal to I. And then the I that only exists inside the for loop and not outside would end up being saved in this var variable. And of course, if you just run this, you can see that the var variable then holds the last value of I before it was rudely interrupted by a break. So I just wanted to let you know that, maybe for some reason you want to use I outside of your functions or your loops or your for loops, even more specific. It does not exist outside of the for loop. It only exists inside of the for loop. And as soon as you quit it or stop it, this I is then gone or disappeared or whatever. And the same goes if you have nested functions or nested fors. Why am I confusing that? Or nested fors, which indicate that the j inside or the I or any counter only exists inside of their own loop until, of course, we start repeating them again. So that means that the consequence of that is that we can write another for loop like this, and this would also work just because this I only exists inside of this for, and this I is a completely separate I that only exists inside of this for. So this is it for now, so let's jump over to the examples. Our first example wants us to create a program that will read 2 console inputs and make sure that they are numbers. That means that we have to check the type of the values that the user has entered, and if they are not numbers, keep asking him to enter numbers until he eventually does. And the second part of the program is when we enter both numbers, or we make sure that the user has entered both numbers, then we will output a rectangle. The first number dictates how many lines our rectangle has, and the second line dictates how many columns it has. So the first example in this case wants us to create a program where we will enter numbers, and when we enter 2 numbers, then we output a rectangle, and we can check if the number So our first program wants us to make sure that the user has entered 2 numbers, and then when we are sure that there are 2 numbers inside, then we want to output a rectangle. And we can kind of check if the user has entered a number by using the type function we learned in the previous videos. So what will end up happening, because we do have a while loop, I first of all create two variables called n1 and n2, which just stand for number 1 and number 2. And then we check in a while loop if the type of n1 is not a number, and if it's not a number, we keep repeating this while loop. And what this loop does is, first of all, tells the user to enter a number, and then we read the number and then we transform it to a number. And if that is successful, we get a value of whatever we entered in n1, and the type of this variable becomes a number, which means that this is false and this breaks. So in essence, what this while does is just checks the type of n1, and while it is not a number, it keeps asking the user to enter it until we finally enter a number, at which point this while stops, or the condition is met, or is false, however you want to put it, and at that point the while loop is exited. And the same thing happens for the second while loop, which is the same thing just for the variable number 2. So what ends up happening when we are sure we have 2 numbers, we end up creating 2 double-nested or a double-nested for loop, which goes from 1 to the number 1 and from 1 to the number 2, and that serves as our way of creating the rectangle. So the outside loop, only what ends up happening is, let's just simulate it because I think it's going to be easier to understand. So first of all, we enter these 2 loops, and j is 1 and I is 1. And we output 1 star. And because the n2 in our example is 2, we output another star, because this loop of course repeats twice. And then we create a new line with the function print. By the way, IO_write is similar to print, but the difference is, in this case, is that we output a star, a character, without a new line. Because when you enter or write print, what ends up happening is that it outputs whatever is inside of the print as well as a new line, but in this case we don't want that. So IO_write is just a way to do that without having a new line. So we output 2 stars next to each other, so these are 2 stars when you look at them, and then when the inner loop finishes writing the inner stars, the outer loop actually creates a new line. Just the print means a new line, so we go to this point. And then the outer loop gets incremented to 2, which is indicating that this is the second line. And then we go in the inner line again, and then we output 2 stars again. And then the outer loop creates a new line again. We go to the third line, and the inner loop then writes 2 stars again. So in a sense, the outer loop creates new lines, while the inner loop is creating columns. And this is just the simplest way I could think of creating this, and of course, because this is maybe a bit more difficult challenge, because it does have 2 nested loops and it does have 2 whiles, these are some things that you need to get used to do examples of, and then you kind of learn it while you do it. And this is not something I explicitly covered in my tutorial series, but at the same time, you do have an example here, you can play with it, kind of experiment, and hopefully learn from that. Our second example wants us to create a fictional item which will increase Isaac's HP regen from 5 to 10 whenever he's below 20% of his maximum HP. And the template for this program looks like this. First of all, we create one main loop that will loop until our current HP is lower than our maximum HP, so until we are fully healed. In the loop, we have to check if we are below 20% of our maximum HP, and if we are, we will increase our HP regen. At the end of the loop, of course, we have to increase our HP based on how much HP regen we have, and we'll keep doing this until we are fully healed. The starting values are our max HP is 100, our current HP is 1, and our default HP regen is 5. Okay, so for our second example, I wanted to simulate how we would go about creating some actual items for the game if we were modding or whatever. And this item wants us to increase our HP regen from 5 to 10 when we hit 20% or less of our maximum HP. So we have some variables here which indicate our max HP, our current HP, and our current HP regen. And what ends up happening is, first of all, we have a while loop that continues until we are fully healed. So this kind of simulates us healing over time. And then we check if our current HP is lower than 20% of our maximum HP, and if it is, our HP regen becomes 10, and if it is not, our HP regen goes back to our default 5. our current HP then gets increased by however amount of HP regen we have, and we print that out. And that repeats until we are fully healed. So in this case, you can see what ends up happening is, first of all, we have 1 current HP, and that is less than 20%, so our HP regen is 10, so that means that it gets increased to 11. And then we go to another loop, and 11 is still less than 20% of our maximum HP, so that gets increased to 21. But at this point, we are not below 20% of our HP, so our HP regen goes back to our default and it starts increasing by 5. This is not a very technical example, it's maybe a bit weird, but I just wanted to showcase how we could use Lua to maybe actually write some code for a fictional item that we could then implement in our actual game. Our third example is a small hangman game. I just want to show you what is possible to do with just loops and if statements at this point. And what this program does is take our guess and see if it's the same as the solution. If it's not, we first check its length, and if it's different length than our solution, we tell the user by how many characters he missed the actual solution. And if the guess is the same length as the solution, then we tell which characters match or are the same in the solution and the guess. So I don't expect you to actually do this by yourself, just watch the example, download the code and maybe play with it a bit yourself. Okay, so the last example in this situation is just something more of a showcase than me actually expecting you to write it, because it's still a bit advanced and I know that these things are still kind of new to a lot of you, but still I just urge you to maybe download it, play with it, kind of change some code around to see how it works, and then maybe you'll figure out something on your own. And how this little game works is, first of all, we enter guesses, and our solution in this case is Polyphemus, and we enter our number or our guess, our word. What ends up happening, it tells us if we are off by how many characters. So that means that if our actual solution is longer or shorter, it's going to tell us by how much we have missed. And let's say that some of our characters that we guess are correct and some of them are not. It would then tell us that our guess is, I just guessed Poly for whatever reason. It will tell us which of these characters matches. So that means that the first 4 characters match our actual solution. And in the end, of course, if we just guess the right word, Polyphemus, all characters would match, and it would tell us that we guessed the right word. So I urge you to maybe download this, maybe give it an experiment, maybe change the solution a bit to see how it works, and just play with it to maybe hopefully learn something new. Of course, if you have any questions, please, I urge you to ask them. There are some functions here that I haven't explained before, but of course if you do a quick Google search, you'll get a deeper insight into them. Of course, you can always ask if you're maybe really interested in how some of these things work. I'll commentate all of this so you know what is going on, and then of course I'll be uploading it and putting it in the description like I usually do with these examples. So this is the end of this video. Hopefully you'll learn something new, and hopefully I did explain these things rather well. Of course, remember, if you have any questions or if you feel that I didn't explain something well, please, I urge you to ask them. I'll be more than glad to answer you. If you want to see the next video, click the screen right now when it's out, or go to my channel and find the playlist if you want to see any of the previous ones. I thank you guys for watching, and I hope to see you next time.